Hi. So as promised, this is the video key for some of the homework problems that you had for practice homework this week. So we'll be doing problem number 24 on page 306. So as you can see, I've drawn, we sketched the normal distribution. And I've put in here also, I've showed the z-axis, where we show from -3 to 3, as well as the x-axis. And this comes from, in the problem, it tells you that the mean is 749, so that's right here. And the standard deviation is 225. So we go, to go one standard deviation below the mean, we take 749 minus 225, and then minus another 225 to get 299, and minus a final 225 to get 74, and then we go up by 225 up here. So that's what the sketch looks like. And the question came up, why do we have z's and x's in the same problem? We can go back and forth between z and x using this formula, z equals x minus mu over sigma, like we talked about in class. And what happens is on these problems where they're looking for the probability, they'll start out in terms of x, and then to be able to find the probability, we'll convert it to a z. And then we know how to find the standard normal probability using the norm.s.dist function. So we'll do that. And then on the inverse normal problems, and those are the ones where they say, find the value of x that corresponds to the top whatever percent, or the bottom whatever percent, or the middle whatever percent. On those problems, we'll first find the value of z, and then we'll convert it to x. Okay? So z and x are kind of like converting from inches to centimeters. They're two different scales, but they mean the same thing. All right, so here's our setup. And for problem part A, they say find the probability, so P of the family expenses for the weekend is less than 400. All right, so that's P of x less than 400. I know that's a little bit awkward spacing, but I want to be able to do the math in Excel. So now we have to convert that to z. And to do that, we will subtract. We'll do 400 minus the mean divided by the standard deviation. And we've done the same thing here to get from x to z. And let me point out here that until we subtract the mean and divide by the standard deviation, it's x. As soon as we do that conversion, then it becomes z. All right, so you got to make sure that you're changing from x to z at the right time. So the probability that x is less than 400 is the same as the probability that z is less than 1.551. And you can go over here and see that that 400 is right about here, and that is about the same as negative 1.551. All right, so you can see this line right about here. All right, and this is shaded to the left, so we're looking for less than, and then so to do that, we're going to do norm.s.dist, and we're looking for the value of, we type in the value of z, true, and that is less than, so we don't have to do any conversion there. We make that a little bit bigger so we can see some more decimal places. So the answer there is 0.0604. So that's part A. Part B, almost exactly the same, but it's greater than. So probability that X is greater than. Technically this is greater than or equal to, but if you remember, greater than is the same as greater than or equal to. Let's see, 800. So that's the same as probability Z is greater than. And we'll convert to Z, so we'll take this value of X minus the mean divided by the standard deviation. Close that parentheses. And norm S dist. Now if we just do norm S dist of that value, it's going to give us the area to the left, but that's not what we want. We want the area above, so we're going to do 1 minus that. And that's 0.4103, and if we go back over here, we can verify that that looks like it's about right. So 749, so it looks like 800 would be right about here, so 800 on the X is right about where a Z of 0.227 would be. So that's part B. Part C says the probability that the family's expenses will be between 500 and 1,000. So the probability that X is between 500 and 1,000. So I'm just gonna convert. So 500 minus the mean divided by the standard deviation there, and I'm going to do the same thing here. 1,000 minus the mean divided by the standard deviation. And now this is Z that we've done that conversion. So now that we do that, if you remember, there we go. To find a between probability, you do the probability of the bigger one, subtract the smaller one. So we've done the bigger one, and we subtract the smaller one. The smaller one is that true. And here I typed in 1.116, although we could just do the cell reference there instead. All right, so our answer there is 0.7335. And again, we could go over here and look and see if that looks about right. So let's see, an X of 500 is right about here. That does look like it's about negative 1.107, so that's good. And then 1,000, 1.116. Yep, that looks good too. All right, so that's part C. Part D is going to be a little bit different because in Part D they say, what would the expenses have to be for 5% of the families to be in the most expensive? So somewhere up here there's a value of Z where 5% is to the right. All right, so somewhere up here there's an area where 5% is to the right. We don't know where it is yet, so I'm not going to draw the line. But, so let's go down here. The first thing that we're going to do is we're going to find what this value of Z is. and then we're going to convert it using this formula. So the value of z with 5% of the area to the right, that's the same as 95% of the area to the left. So norm SINV 0.05, except it should be 0.95, because if there's 5% to the right, there's 95% to the left. So 1.6449. So we know that that value is right about here. So 1.6449. And we're looking for this area here over to the right. And we know this area is 0.05. I'm trying to draw with my mouse, which is a little awkward, but so that area is 0.05. We know that the value for z is 1.6449. And so the value of x then, we could solve this for x. And when we did that in class, we get that x equals z times sigma plus mu. So we'll just come down here. That's our value for z times sigma plus mu. And so we get our answer is 1,119.10. And let's just double check it, make sure. Does that look like it's about right over here? It does indeed. All right, so feel free to send along any questions if you have them.